In this presentation, we are going to find magnetic field on the axis of a solenoid. So before moving on to solenoid, we have previously calculated magnetic field on the axis of a circular coil. A circular coil of radius r, we have found the magnetic field at a distance z from the center on its axis is determined as mu 0 I r square by 2 into r square plus z square to the power 3 by 2. We will use this expression in solenoid. So first know what is a solenoid. It is a conducting wire. When it is wound over a cylindrical shaft, it becomes solenoid. We saw a spring. This spring is like a solenoid when a current passes through it. Now, for theoretical calculation, we redraw this solenoid like this. This is the diagram of the solenoid. Here, we are taking a small part dx, elementary length, and we will calculate the magnetic field produced by this elementary length dx. So dx is the elementary length which contains a current mu 0 n I dx, right? Here n is the number of turns of the coil per unit length. Now this makes angle d theta at the point where we are going to find magnetic field, and this point lies on the axis of this solenoid, and we are taking this solenoid of radius r. The total length of the solenoid is capital L. Now calculation of magnetic field. To calculate magnetic field, we will draw this diagram. This is the portion of elementary portion dx, which contains n dx number of turns, and it carries current I n dx. So basically we are going to find the magnetic field produced by I n dx at distance x from its center O. Now here the direction of the magnetic field is shown along this arrow, and current is passing through this coil along this arrow. Now the calculation. From this figure we get x equals to r cot theta. After getting differentiation, dx equals to r d cot theta, because r is constant, and d cot theta is minus cosec square theta d theta. So we find dx equals to minus r cosec square theta and d theta. So we put these two values, x equals to r cot theta and dx equals to minus r cosec square theta d theta. We get dB equals to mu 0 by 2 I n dx r square by r square plus x square to the power 3 by 2 equals to mu 0 by 2 I n r square dx by r square plus x square to the power 3 by 2. Now we put this value of dx and x. What we get? Mu 0 by 2 I n r square minus r cosec square theta d theta. This is the value of dx, and we put x equals to r cot theta, and x square is r square cot square theta to the power 3 by 2. Now further simplifying, we get mu 0 by 2 I n r cube cosec square theta d theta divided by r cube into 1 plus cot square theta to the power 3 by 2. Now this r cube and r cube wipes out, so we find dB equals to minus half mu 0 ni cosec square theta d theta divided by cosec cube theta. Further simplifying, we get dB equals to minus half mu 0 ni sin theta d theta. Now to find the total magnetic field, we should integrate this part. So to find total magnetic field, we integrate the above equation. B equals to half mu 0 ni integration theta 1 to theta 2 minus sin theta d theta. And this value of this integral becomes mu 0 ni by 2 cos 2 theta cos theta 2 minus cos theta 1 after putting this limit theta 1 and theta 2. So basically we find magnetic field due to the solenoid. This is the expression, final expression. So what is theta 1 and theta 2? In this picture, by taking this limit theta 1 to theta 2, we just cover the whole length of the solenoid L. So the final expression is mu 0 ni by 2 cos theta 2 minus cos theta 1. Thanks.